Hello friends, in today's lecture we will discuss the first shifting theorem of inverse Laplace transform. Friends, as I had discussed in Laplace transform of first shifting theorem, we have given the lots of examples related to the first shifting theorem in inverse Laplace transform. So in today's lecture we will discuss the first shifting theorem of inverse Laplace transform. So let us see the theorem of first shifting theorem of inverse Laplace transform. This is the statement: if L inverse of Fs equal to Ft, then L inverse of f of s minus a equal to e to the power at into Ft. And here Ft becomes, because Ft is known as L inverse of Fs. So this is the statement of first shifting theorem of inverse Laplace transform. Again I repeat the statement of first shifting theorem of inverse Laplace transform. If L inverse of Fs equal to Ft, then L inverse of f of s minus a equal to e to the power at into Ft. So this equal to e to the power at into L inverse of Fs. Now see the proof. By the definition of Laplace transform, we have Fs equal to 0 to infinity e to the power minus st into Ft dt. So this is the basic definition of the inverse Laplace transform. Write down, this is equation number 1. Now here, on replacing s by s minus a, on replacing s by s minus a, on the both sides of the equation 1 we have, the equation becomes f of s minus a. Here is s, so s becomes s minus a. So f of s minus a in the left hand side, and in the right hand side integration as it is 0 to infinity e to the power minus of s minus a of t ft. Now this integral can be written as 0 to infinity e to the power minus st of e to the power at into ft. Now this part is, suppose this part is known as like gs. So what is the form? This is the actually form of the Laplace transform. Integration over 0 to infinity e to the power minus st into ft. So this is the Laplace transform of e to the L of e to the power at into ft. तो देखिए यहाँ पे हम लोगों ने देखा क्या कि 0 to infinity e to the power minus st of, suppose this part is known as ft. So what it becomes? It becomes the form of Laplace transform. So this expression can be written as L of e to the power at into ft. So this becomes f of s minus a equal to L of e to the power at into ft by the definition of Laplace transform. Hence by definition of inverse Laplace transform we get, so L should be transferred right to left. It becomes L inverse of f of s minus a equal to e to the power at into ft, and here ft is known as L inverse of fs, so it becomes e to the power at into L inverse of fs. This is equation number 2. Actually this is the proof of first shifting theorem of inverse Laplace transform. Now suppose we have the another statement like L inverse of f of s plus a. What is this? L inverse of f of s plus a. So it becomes e to the power minus at into ft. Same as here we have indicated in the form of remark. Remark number 1, replacing a by minus a in equation 2 here. So it becomes L inverse of f of s plus a, and the result becomes e to the power minus at into f of t equal to e to the power minus at into L inverse of fs. Now in practice generally we apply the first shifting theorem in the following form: L inverse of f of s minus a equal to e to the power at L inverse of fs, and L inverse of f of s plus a equal to e to the power minus at into L inverse of fs. तो इस तरीके से ये दोनों फार्मूला आपको याद रखना है फॉर यूजिंग द first shifting theorem of inverse Laplace transform. Now the remark number 3, the result of the first shifting theorem can also be expressed as in the form of L inverse of Fs equal to e to the power minus at into L inverse of f of s minus a. This can be written here also. L inverse of Fs equal to e to the power at into L inverse of f of s plus a. So this is all about the first shifting theorem of inverse Laplace transform. Now let us take examples. See the examples of related to first shifting theorem of inverse Laplace transform. Solve by inverse Laplace transform of the following examples. Example number 1, s minus a divided by s minus a of whole square plus b square. There are lots of examples related to the first shifting theorem. First you see at a glance, and then you decide actually this is the form of first shifting theorem, this is the form of another property of the Laplace transform, like this. So here is the problem, s minus a divided by s minus a of whole square plus b square. Similarly, s plus a divided by s square plus 6s plus 25. And another example is s divided by s plus 5, s plus 1 of whole to the power 5. So see, L inverse of s minus a divided by s minus a of whole square plus b squared. So it becomes e to the power at L inverse of s divided by s square plus b squared by the first shifting theorem. Because we have already learned in the statement and their proofs of first shifting theorem, it is the form of L inverse of s minus a form. So it becomes e to the power at into ft. So what is ft? Ft is s divided by s square plus b squared. So here we have written all these things. L inverse of s divided by s square plus b squared. So e to the power at as it is, and now this is the basic result of inverse Laplace transform. It is the form of cos bt. So this is the result of first example. Similarly, L inverse of s plus 1 divided by s square plus 6s plus 25, it can be written as the first, you convert the denominator in the perfect square, it becomes s plus 3 of whole square plus 4 square. Now s plus 1 can be written as in the form of s plus 3 minus 2. So again we try to use here the first shifting theorem, and it becomes e to the power minus 3t. Means first remark what I have indicated in the theorem, L inverse of s minus 2 divided by s square plus 4 square. So it becomes e to the power minus 3t as it is L inverse of s divided by s square plus 4 square minus of 2 L inverse of 1 divided by s square plus 4 square. This is transfer in the two forms of inverse Laplace transform, s divided by s square plus 4 square minus 2 divided by s square plus 4 square. So e to the power minus 3t as it is, and now this part becomes cos of 4t minus 2 as it is, and the second part becomes 1 by 4 of sine of 4t by the elementary property of the inverse Laplace transform. Now e to the power 3t as it is cos 4t, and after cancellation it becomes half of sine of 4t. So this is the second result of. Now the third problem, s divided by s plus 1 of whole to the power 5. Similarly, because here the denominator in the form of the perfect power of s plus 1, so the numerator can be transferred in the form of s plus 1 minus 1. So e to the power minus t L inverse of s minus 1 divided by s to the power 5. So it becomes e to the power minus 3t, e to the power minus t L inverse of 1 by s to the power 4 minus L inverse of 1 by s to the power 5, and it becomes e to the power minus t as it is, and by the elementary property of inverse Laplace transform it becomes t to the power 3 divided by factorial 3 minus t to the power 4 divided by factorial 4. So it becomes 1 by 24 e to the power 3 e to the power minus t of 4 minus t. Similarly, the fourth and fifth problem you can do yourself. Let us take another example. See the another example of the based on the first shifting theorem of inverse Laplace transform, if L inverse of ft equal to s plus 4 divided by s square plus 4 s plus 8, find ft. Here the same problem. First we denote here L of ft. L of ft is given as s plus 4 divided by s square plus 4s plus 8. This is equation number 1. Now again we transfer first the denominator in the form of perfect square, so it becomes s plus 2 of whole square plus 2 square. Now numerator can be transformed in the form of s plus 2 plus 2. Now by using the first shifting theorem, it becomes s plus 2, so e to the power minus 3t. When it is plus, then write down e to the power minus 2t, and when it is negative, then it becomes positive. E to the power minus 2t L inverse of s plus 2 divided by s square plus 2 square. Now again this inverse form can be transformed in the two forms, like e to the power minus 2t as it is L inverse of s divided by s square plus 2 square plus 2 of L inverse of 1 divided by s square plus 2 square. So it becomes e to the power minus 2t cos of 2t plus sin 2t by the elementary property of inverse Laplace transform. So this is all about the first shifting theorem of inverse Laplace transform and their related problems. So thank you all.